This is an introduction to cloud for HPC. Quick show of hands, how many people here got an HPC background? So, fantastic, the whole room. That's brilliant. I was a little worried in case I was going to walk into a load of cloud experts. So, primarily, what we're going to look at today is we're going to look at how HPC can benefit from cloud technologies. Now, in order to do that, we've first got to get a definition of what cloud computing is, and then we've got to look at what HPC Cloud is. And then after we've done that, we're just going to get a sort of sky view overlook of what Moab HPC Enterprise Edition can offer you in terms of cloud functionality. And then we're going to go for the big one, Moab Cloud Suite, and look at all the cool stuff we got in there. So, quick introduction of myself. My name's Daniel Croft. The dodgy accent is because I'm from the UK side of the business. I primarily do HPC systems integration and system support. Effectively, what I do most of my day is I spend it talking to customers. So all of this, the reason that Al gave me this project, it was simply because I'm there talking to HPC customers, and I'm not someone who's going to come in and give you a load of buzzwords about cloud, because it's brilliant, but if you're not from a cloud background, I found as soon as I started researching this, I got very confused about what all these different terminologies were being thrown around at me. Now, a lot of the work I also do is supporting the sales efforts in Europe, and we've been sort of going out with a few customers, and they've been looking, like yourselves, to dabble into cloud and just see what it can offer. Now, as far as I'm concerned, there are only two things that I really care about at giving a customer, which is giving them better value for money and making their jobs easier. You know, if it's going to be a cloud solution, if it's going to be an HP solution, or if it's going to be a combination of the two, it's not really a matter of that. It's just getting the right solution for the right problem. So let's jump into the big question. What is cloud computing? Well, I went out to a couple of presentations on cloud computing. We've just had one from our good friends at HP, and also gone to about 10 or 11 different cloud companies just to try and come up with an absolute solid definition, one beautiful line that says exactly what cloud computing is and what we're trying to achieve. And I quickly found, unfortunately, that over the last couple of years, it's become far too broad. It's being labelled everywhere. And it's an inhibitor to getting people the knowledge they need about cloud computing. So what I'm going to do is take a different stance on this. Rather than coming up and saying, okay, this is what I think cloud is and this is why I think you should use it, I'm going to say, here's our 5 key points that any good cloud solution should offer you, which have been published by Gartner. And a lot of these you're going to see have got a lot of crossovers with what work we do with HPC. Now, number 1 is service-based. Now, I would make the argument that all HPC solutions are service-based because we're serving to a customer base. We are not doing this just for fun. We are putting a solution in place for our users to use so they can get their work done. So we can deliver projects that need very unique hardware to succeed. Second one is scalability and elasticity, it really should be, but that's what they put on Gartner's website. Effectively with HPC, we haven't had traditionally a great history with being able to scale our solutions. What will normally happen is you'll go out to tender, you will do all of the research, you'll speak and see all the applications that you need to support, and then you'll go and get this fantastic bit of kit, spend a lot of money on it, but then once it's in place, that's your lot for the next couple of years. If you want to then go and migrate to a different operating system on all of the nodes, you're going to have to start putting in a provisioning agent. If you want to be more dynamic and scale out to other places, HPC traditionally it hasn't really done that at all. Now cloud is very young, it's come in with a lot of features like this. So we can go in and we can do these things because we haven't really got, shall we say, the history in HPC to accommodate. Also, we have attribute that needs to be shared solutions. We do it in HPC, but we're just taking it a step further in cloud. And the last two, which is metered by use. I'll be honest, it's my favorite one. I think it's absolutely vital that everything we do in HPC, or we do it in a cloud solution, has to be metered. has to have some sort of cost involved in it. Even if we're not going to take that on and have a charge for it, it's important that the end user knows that these solutions that we're providing them, they're not free. Final one is the use of internet technologies. It's dependent on if you want to do a public or a private cloud. I would say mainly what we're interested in is private clouds, because you're going to have your own internal infrastructure. And as our good friends at HP pointed out, it's very difficult to get large data sets migrated back and forth between a public and private cloud. So, HPC Cloud. So, I don't know if you guys have come across this definition, but what I want to do with HPC Cloud is I want to take all of the virtual infrastructure that you're traditionally going to have with a cloud environment, and I want to mirror that with what I call direct access. So that's what we've got now. So we've got systems with one operating system running one job, which has got hard-coded InfiniBands, to make the job run as fast as possible. So this is what we've got in the box for HPC Suite Enterprise Edition. Now, we did a few changes around with our product sets. So a lot of you may not be familiar with the terminology that we now use. We've got HPC Basic Edition and HP Suite Enterprise Edition. I would check back with our agent if they're here and just find out which version that you've been grandfathered into. What we've got in the product that we're starting off new with is we've taken off and we've changed the viewpoint portal. So we had a brilliant presentation yesterday about it. The reason that we did that was purely from user feedback. Previously, we were using the Java API in order to interface. We found it was too slow. If you want to be in a cloud environment or even a larger HPC environment, it's all about scalability. Previously, in 6.1, that was all we concentrated on. And this is what we've got in the product now. So underneath the portal, you've got the Moab Intelligence Engine. That's the battle-hardened engine that we've been using for the last 10 years. Scales into the hundreds of thousands, now 1 million jobs that we can support. And then what we've got here is all the different APIs. These are going to be the arms and legs. We keep coming back with this analogy. We've got the brains here of Moab, and then we've got the arms and legs. This is what's going to reach out onto my resources, and it's going to set things up for me. So we've got resources like Torque and Slurm that we're used to, health monitors like Ganglia and Agios, provisioning managers, so we talk about CMU in that instance, we talk about XCAP. Storage managers in an HPC environment were more concerned really around data staging. So trying to get the data out to the nodes before the job starts. And then with network managers, that's really more going to be a case with a private cloud, setting up VLANs to just subnet and segment the network. On the side also, we're going to introduce this new thing, which is cloud bursting. And that is inside Enterprise Edition. Right now, it's a professional service engagement, but it's available to everyone who's got Enterprise Edition. Right. So if we go back to these 5 points, what are we going to do to get HPC more cloud-like, should we call it? The main thing that I find when I talk to customers is they want to broaden their audience, the amount of people that can come and use their HPC facilities. And the biggest hurdle that I see, is that it's going to be the user interface. Now, it's fantastic if you've got a lot of, for example, IT and engineering backgrounds, if they're going to be sitting there and doing a command interface. And these guys are very intelligent, PhD level of intelligence, and yet still you're running into an overhead because people are making simple mistakes on the command line when jobs are submitted. Now, Moab does a pretty good job of telling you if you've just asked for something silly, but if you go and do something small, like you've asked for 7 licenses when you only required 1, what's going to happen is the job's going to go into Moab, it's going to be queued. You may not even notice that it's been queued and it's wrong, and then as soon as the job comes to run, that's when it's going to fall over. Now, we can cure a lot of those problems by just having a really simple user interface that customers just get online, submit their workload, and get it up into the cluster. On top of that, what we've done is we've now offered a new user interface, which is directly for the Cloud Suite. The Cloud Suite is primarily based around this idea of offering a service. So we've just sort of taken a step back, and instead of saying to a customer, okay, you tell me what you want. Do you want 10 nodes? Do you want 16 CPUs? Do you want 14 meg of memory? That, for a really hardcore HPC user, may be ideal. that if you want to expand outside of that safety zone, you want to actually have their own service where you say, well, hang on, here's 15 VMs that we've already created, and we've already got defaults set there, and you can look at them. And a couple of these resources we're going to let you change. But what we could really do, which would be fantastic, is we could create a one-click solution. Because if we want to go outside of HPC and its traditional audience, we've got to just scale to what they want. And that's really sort of one of the primary rules of what cloud is all about. Other thing which I absolutely love, Moab Accounting Manager. So this is superseded gold, and it comes back to this idea of having things metered by use. Now, it is here, as I'm showing an introduction to cloud, but it's much more than that. I would say every HPC user needs to be doing this, because we all know what happens in an HPC environment. You've gone and got a brand new system. It's cost you millions of dollars, and you've got to show that it's proved value for money. And what do you do at the end of the year? You're going to go out and you're going to go and get all the stats you can find. You can find your CPU stats, your core stats, all of your utilization figures. The person that you're talking to may not be as technical as you are. It's a worry as you go further up an organization, but I'm pretty sure it's true. So what they really want to know is, I spent $5 million on this machine. How much of my return did I get for that? So a very clear cut of Moab Accounting Manager that you can do that just to make your lives a lot easier. Take the amount of money that it costs for that system. Take the amount of money that it's going to cost you for the continued support of that system, and then divide it by the amount of CPU minutes that it's going to provide you over its lifespan. That's going to give you a number for how much it's going to cost you in dollars of how much each minute is going to be worth on that system. Now what you can do is you can link up Moab Accounting Manager, and you can, even if you don't want to worry about assigning credits to people, or you want to just have a debit system, all you need to do is just have that little number in the corner, because it's just a different type of workload. Because you're changing people's perceptions of how an HPC organization is run. Every time someone's submitting a job through to the cluster, they've got a number there which says, even though I'm not going to charge you this, I just want you to bear in mind that if you run this job over 14 nodes for 2 weeks, it's going to cost you about $2,000. And then what you can do is you can take those statements of all of those different accounts, and we can combine them into set projects which you have defined. And then suddenly you've got a very powerful tool at your hands, because you can go out and you can say, well, you know that project that we took on, that, I don't know, we took 10 million or something for that project. Well, I can tell you that through infrastructure cost and through the tender that we had for this system, that we've taken, it's cost us about 1 million. So we've made, X amount of millions of profit from that deal. And I think that is a much more powerful tool of getting up and getting more money so that you can expand your infrastructure, so you can convince your heads of departments that what you're doing is worthwhile, rather than going and showing them lots of lovely graphs of saying, yeah, we've got loads of CPU utilization, we've got loads of memory utilization. We can have that later, but that really, we want to have that upfront conversation of, this is worth it. What we are doing here is making us money. Other thing as well that we can do with Moab Accounting Manager is we can start coming into this idea of, now I'm assigning, if we decide we're going to assign credits to projects, we're going to be proactive. Rather than just seeing how it works out, how much a project ended up costing because they just kept submitting jobs into the cluster, it ended up going over budget because we know how much it's costing us in real time. We could say, okay, here's an idea. We're going to set a budget. We're going to set a budget over a project's life cycle of 10 months. And we're going to assign credits for that project. But the fun thing what we can do is we can have a start and an end date for each one of those assignments. So we can say, let me just go back to this for a second, so I'll just put this in context. So here we go to a project. This is normally, unfortunately, what happens with most people's projects when they run on this HPC system. We start off at the beginning, and that deadline is 1,000,000 miles away. We don't need to worry about it. We're going to go do something else. I'm going to talk to my girlfriend. We're going to chill out. We're going to have lots of meetings, but we're not going to need to use this system just yet. Halfway through the project, we haven't really got a lot done, guys. We better kick this into gear. Let's get it done. Let's start ramping up, and we're going to get this work done. And oh no, we've now got a deadline which is a week away. We need this entire machine. Luckily, you've got very understanding sysadmins. They let you have the machine, but unfortunately, you then hit this point. The machine's capacity physically cannot guarantee that your project is going to finish on time. Now, there's two ways that you can solve this problem. The first way is that we can start putting this allocation of funds to this project. And we can change it, and we can say, okay, look, I'm not just going to give you 100,000 credits just for you to go and, when you decide you're going to go on the system. What I'm going to do for you is every month, I'm going to give you 10,000 credits. In total, you'll still have the same amount. But it means that within the first month, you have to have used that 10,000 allotment. The second month, you must use that 10,000 allotment. So we just want to raise the bar here, just bring that amount of productivity up at the start of a project so we can just avoid this situation. Now, unfortunately, projects are run by humans. Humans are kind of a little bit temperamental. You might have a few guys go on holiday, and you just can't avoid it. You've gone up to this point, and you haven't got enough capacity in your system. And for a traditional HPC environment, well, you're going to have to start making some friends with another institution, start going and provisioning some more machines, seeing what you can do. Or most likely, your project is just going to overrun. However, there is another way, Moab cloud bursting. So this is something new that we've been toiling with in the labs, which I'm really excited about. So the idea of it, it's very simple. You've got a Moab cluster here, you've got your resources here, and underneath you've got a talk server. On top of that, you've got a cloud bursting service. Now, all that, a brilliant name, isn't it? So, what that's going to do is we're going to have a talk server here, but in the cloud, or on just another environment, we're going to have another Moab server with its own resources, but it's going to be talking to this talk server. It's not going to have its own talk resource manager. So one talk server is going to manage all of these resources. And that produces a lot of flexibility. What we can do is when CBS notices that there are no more resources available on the local cluster, it can go and get in contact with this little guy called the EM, or the environment modifier. And it's a very simple service. All that we're going to do is we've set up a reservation here, and we set up a reservation there. That's how we're going to distribute the workloads for these two systems. However, when this guy needs more resources, he's going to talk to the environment modifier, and he's going to say, okay, are there any free nodes that you've got? Is there any free capacity that I could use? If there is, then what he's going to do is he's going to change the reservations on this side. He's going to take the node out of this reservation, and he's going to put it here. That's very simple because we're not doing anything different on this side of the cluster. We're just saying you keep submitting your work into that reservation. If that reservation gets bigger or smaller, you don't need to worry about that. You just need to keep submitting your workload. Don't change anything that you're normally doing. Or just maybe get your projects in on time. Now, the second thing is, what happens if this Moab cluster, all of the nodes are utilized? Well, we're back to square one. But not necessarily. What we can do is with the event modifier, you can go and look at all of the work that's available on that, that's currently running on that secondary cluster. And it can say, okay, well, we've got a couple of real low priority jobs here, and they've been marked as preemptees. So you know what I can do? I can jump in and I can preempt this workload. And then I'm going to have some nodes freed up. So I can facilitate my initial requirement, which is to get some nodes available for this user to do their workload. So it's a pretty nifty system. It's available as a professional service, and it's available in Moab Suite Enterprise Edition. So that's what we've got in our Enterprise Suite. Now we're going to move on to the Big Daddy. This is all going to fill up in a minute, don't worry. So Moab Cloud Suite. So this is the big product that we've been working for through the winter. You've got a lot of developers who've just got that 10-mile stare. They've been burning themselves pretty hard. But what they've come up with is pretty unique. What we've got is we've got the same self-service portal. But what we're doing now is we're selling services to customers. So we're not going on, we've taken it a step further, as I said previously. We're going to allow them to come in and they can modify a few things to that service, or it can just be a one-click solution. On the back end of that, we've got an administrator dashboard. So the administrators as well are going to benefit from this because they are going to be able to go onto a GUI environment and create these services dynamically. Underneath it, we've got the same version of Moab. So everything that you know and love about Moab is going to be in the Moab Cloud Suite. So this is the way that we're going to be able to combine the two different workloads. We're going to have a cloud type workload and we're going to have an HPC workload. But with this, we're going to have job templates, we're going to have classes, we're going to have user and accounts limits. So we're not going to be coming in with a brand new product that's not going to be fully fledged. We've got a 10-year-old project that's just been enhanced to support cloud user base. Next to this, we've got Moab Accounting Manager. Interesting change to Moab Accounting Manager, and you will get the same version if you have enterprise or if you have cloud, is that it can do periodic charging. So with an HPC environment, we're always used to this idea of everything has a beginning, a middle, and an end. If we're in a cloud environment, we may not have that. We might just have services that run indefinitely, and we need to be able to charge for that. So we've now got that support in Moab Accounting Manager. Underneath this, we've got an integration layer and a set of APIs. So this is the same one that we're going to use to interface with all of the resources that we're going to be managing within our cloud space. And those are the simple guys that you know. So the Virtualization Manager, this is what we're going to be using to create the VMs. License Manager like FlexLM. Storage Manager is a little bit more complicated. So we're coming up with this idea of being in a public cloud so we can have massive silos of storage. And when a VM is migrating around the different clusters, it's going to need access to different storage units within that environment. Networking Manager as well. If we're going into this idea of a public cloud, we have a lot of resources, a lot of jobs that may not play well together. So what we want to do with the Network Manager is VLAN them off. Case in point, if you've got you've got an entire infrastructure that you want to set up, you might have 5 or 6 DHCP servers broadcasting all around your network. If you don't have VLAN set up, it's going to get pretty ugly pretty quickly. Next to this, we have the XCAP Provisioning Manager that we support in the Cloud Suite, and also the classic resource managers that you're all used to. And these are just the sort of things that we're going to be supporting, so they're pretty self-explanatory. We've got the physical resources, the OS and applications that we need to provision, the VM images that we're going to be pushing out, the licenses that we said with FlexLM, and then storage and network. Okay, so let's come back to this idea of having a service catalog, because this is going to be a brand new idea that hasn't been done in HPC before. They've been doing it a while with cloud, but this is like our first iteration of it. Now, the idea of it is very simple. You have a GUI interface that your administrator can log on and use, and they're going to create a container. Now, that container, if we just have a nice little diagram of it, is going to create things like, for example, a VM. When you create a VM, as opposed to having a physical request, you have to tell it everything, because it doesn't exist. You have to say, okay, I want a CPU, I want storage, I want networking, and I want memory. I also want this application to run on top of it. Now, the fun thing with the service catalog is you can say, all right, this is my VM. I'm going to let you change the CPU, and I'm going to let you change the memory. But the application and the storage and the net, that's hard-coded, because I don't need you to know about that, because that's back-end infrastructure. However, I'll let you change the application, but with the application, dependent on what your choice is, I need to have some sort of intelligence here that says, if you go and ask for something like a MATLAB a MATLAB application, you're going to need a license for that. So I need to make sure that when this is provisioned, it's provisioned with, I need to push out to a license request for this. On top of this, we have other things like storage. It's going to need a mount point. For NIC, it's going to need a VLAN ID. And we don't have to just have this as one VM. We could have this as any multitude of VMs. We could have 30, but I couldn't fit it on the slide. Here we've got 2 VMs, and they can be statically assigned. They can be dynamic between the users. And on top of this, we can have direct access machines. So just say, I want to re-provision this as a Linux machine with this application, but I want the entire node. And we can mix and match these things for when they get sent out. And then we just leave Moab to do the hard work of getting it set up within the environment. So, we've got this far. We've got into an environment where we've now got VMs and we've got direct access like MPI jobs running in the system. However, it now becomes a very unique situation which we haven't been in before, where we've got to manage both the expectations of a virtualized infrastructure and those of an MPI infrastructure. Now, the first thing that we found when we were doing the testing on this is that with the VMs, as we said, some jobs will start and some will finish. Others will be continued services. But each VM obviously needs a hypervisor. So you might as well have the entire node if you're just going to have to re-provision that as a hypervisor. And if all the other jobs that are running on it finish, we're going to get into a situation where we've got all these small jobs running around the network, taking out resources which we could be using for our MPI jobs. So in this environment, I want to run a 5-node MPI job, and I can't do it. So what Moab is going to do is we've got this thing called Touchless Live VM Migration. It's a funky buzzword. And what that's effectively going to do is pretty simple. It's going to start migrating those VMs into as small a place as possible. And it does this periodically in the network. Now, as you can see over here, I've now got enough space to let my MPI job run, which is fantastic. So we've now got two completely different workloads running side by side. And you can take it a step further if you like. You can use what we call overcommit to start packing as many VM jobs as we can into a smaller space as possible.
I know you weren't allowing any questions, so I'll just make this statement. Our cloud suite is not just VMs. That's one of two different modes. We can have VMs and physical or stateless in the same space. So that's why if you're thinking virtualization, great, it's not applied to me. You can have this with, obviously you can't have the physical migration as easy.
Yes.
But you can have this with physical or stateless provisioning instead of VMs or in addition to VMs.
Okay. So moving on, we also have this idea of auto self-healing trigger policies. It's a bit of a mouthful. So we come back to this same situation where we've now got these two workloads running on the same cluster. It's 3 in the morning. You've gone home. You're asleep. At least I hope you're asleep at 3 in the morning. And what happens is, let's say an aircon unit goes off. It's broken. Any node that is next to it is heating up pretty quickly. And we've got workload that's running on those systems. Now, we've got two problems here, because we've got a VM that needs to be moved, and we've got a physical job that needs to be moved. So what we've got with Moab is the same things that we spoke about yesterday in our presentation about having this idea of reporting up information from different things like Nagios and Ganglia, where Moab can then take that information, set thresholds on that inputted information, and when it exceeds that threshold, fire off a trigger and take some intelligent action. Have some preemptible buys. We've got a very hard-working sysadmin here at 3 in the morning who doesn't want to be woken up. So what they can do is, if the nodes are still online, but they're overheating and we know it's going to go down, we can instantly trigger a VM migration. So we can take those VMs, we can find another node that's available in the system. If it's got a hypervisor on it, then we can just move it straight on. If it's not available, then we can provision a hypervisor and then migrate them. And then we've got these VM jobs are now happy and they're all good again. So that node there, doesn't matter if that fails now because it's got nothing running on it. However, we've still got this other guy, my lovely MPI job. And that's going to blow down 5 nodes if we have this problem. But I can't do a live migration on an MPI job. It's just not possible, unfortunately. So what we would do then is we would have a second trigger system. And what that would have to do is send out a checkpointing notification. So it would send the checkpointing signal to the job. Obviously, your jobs would need to be checkpoint enabled for this to happen. And it's going to take that job down. So now we've got that job off of that problematic node, and we've got these 2 nodes here. But as a lot of you guys in HPC have seen, if you have a node that's a little bit temperamental, you can get a problem where Jobs just keep spamming into that node, failing, and then the queue just gets completely drained. And that's a real problem. So what we've got to do now is we've got to take another step of intelligence. We've got to say, look, we can't run anything else on these nodes. They're too temperamental. Anything that's going to run on this is likely going to fail. So what you can do there is you can set up another trigger to just put a reservation around it. Now that could be a system reservation, which is what a lot of you guys use when you need to take down nodes for maintenance. And all that's going to do to say to Moab as the scheduler is it's going to say, you cannot use these nodes to submit users' jobs to it. And we've already got a job in the queue because we've re-queued our MPR job. An interesting thing about Moab is when you submit a job, it's still going to accrue priority even when it's running. It may not accrue as much priority, but it will still go up. So when your job is checkpointed and re-queued, it will still get the same priority level. And it still should be at the top of the queue. And because we put this reservation in place, when we get this bad boy to come back in, he's going to be able to go to a different subset of nodes, so he's not going to be affected by these two that have gone down. And that can stay around. We can have more jobs coming into these nodes that are available, and these two are just not going to be touched until the morning or as such time as an administrator comes in and fixes them. So I hope this is useful to you. And see how HPC users can benefit from technologies used traditionally in cloud computing. The main thing that I discovered when I was doing a lot of research on this is just to find out what the actual technologies are behind cloud computing, because it is vast and it can be a little bit intimidating when you get a lot of terminology thrown at you at any one time. But there's a lot of really great technologies out there that I think could be very beneficial to HPC users.